Baxter, and I'm Director of the Life Course Centre based here at UQ, and it's a pleasure to welcome you all this afternoon, both online and in person, to this lecture on ethical AI. To commence, it is with great respect that I will invite Gregory Eagert to perform a Welcome to Country. Gregory is known as in the community as Uncle Chegg, and that's how I think of him. He's the Elder in Residence at the Indigenous Futures Centre at UQ, and in this role he guides their research committee and chairs their community and partner advisory board. He is from Yagara, Gurunpul and Kabi country, and has extensive experience in Queensland education and strong ties with many First Nations communities and organisations. So thank you very much, Uncle Chegg.
Thank you. Thanks, Janine, for that lovely welcome. Of course, where we are is on the lands of the Yagara and the Turrbal people. And where this lovely university sits also is smack bang in the middle. And when we cross the river, is mostly Turrbal country, and then on the other side is Yagara, and it goes all the way out towards the bottom of the Toowoomba Range. So my connection to this place is through my mother. And my mother is, of course, Irene Morton, and her mother and father are from Stradbroke Island. And of course our name is like the same as Moreton Island and Moreton Bay. So with that, I have connection to this place. And of course, one of my old great grandmothers was actually born in a birthing creek, which is now a part of Brisbane Botanical Gardens, straight opposite QUT. And her father is, of course, King Sandy of this particular area here. And that's how I get connection to this place. And of course, I'd like to acknowledge our other Aboriginal and Torres Strait Islander people in this room. And of course, we all sit here. We sit here on the legacy of the shoulders of our old people that have gone before us. And without them, I don't stand here with you in this particular forum, welcome you to this place, to Yagara country. In a forum that I can't wait to listen about this afternoon and tomorrow, because of course technology, as an older person, not too old, mind you, not too old, but as an older person, getting my head around wrapped around AI and how it's going to, what's the benefits and what's the impacts it has, not just us as in First Nations people of this country, but the same for Indigenous people right across this world. And of course, Indigenous people right across this world are getting impacted from other forces and other things besides AI at this point in time. So without further ado, look, I'll just say a couple of words in language which is Boka Bi Boka, which means welcome welcome to this place. And I hope, and I not hope, because I know we will, all have discussions and very fruitful discussions tomorrow and today about this very important topic that's going to impact us in the next generations. Not necessarily me, but the ones after me. So with that, thank you very much, and thanks for having me.
Thank you very much, Uncle Chegg. That was great. I too would like to acknowledge the traditional owners and their custodianship of the lands on which we meet today and pay my respects to their ancestors and descendants. So I'm delighted to welcome you all here to this public lecture. And the event was really sparked by our recognition that there's an increasingly urgent need to address what's happening around AI in terms of shaping decisions that affect our daily lives across all sorts of domains. It's becoming ever more pervasive in our daily lives, not just in education, but in healthcare, financial systems, social services, and beyond. And as generative AI tools move from the experimental labs, which they already have, into real-world practice, the questions that we face are not just about the technical performance, but about things like ethics, governance, and the societal impact of AI decision-making. And that's a particularly important topic for us in the Life Course Centre because AI is increasingly influencing the experiences of children, families, communities at every stage of the life and across many domains. And as social scientists concerned with social disadvantage over the life course and things like access to opportunities, it's our responsibility to ensure that the ethical considerations are foregrounded and that researchers, like many of us in the room, practitioners, policymakers and the public have the knowledge, the tools and the capacity to really anticipate the risks that we might face and promote equitable outcomes in a world which will be increasingly shaped by AI. And so it's in response to those challenges that we've partnered with the ARC Centre of Excellence for the Elimination of Violence Against Women, CEVAW, to host this public lecture. And I'd really like to thank Professor Jackie True, Director of CEVAW, and her colleagues for collaborating with us to bring this event to you all. Our keynote speaker for today is Professor Shonali Krishnaswamy, I knew I would get that wrong, who brings amazing expertise and experience at the intersection of research, innovation and industry. And her insights today, as I understand it, will provide us with a practical 5-step framework for moving from AI experimentation to responsible deployment and hopefully helping us to ensure that technological progress aligns with the ethical and social responsibilities. Shonali is Academic Director leading AI innovation at Monash University, and she's also Director of the Monash AI Institute. She was telling me she's only been back in Australia about a year from Singapore, where she was the Chief Technology Officer and co-founder of AIDA Technologies, I hope I pronounced that right, a multi-award-winning machine learning startup from Singapore, which was delivering AI-based claims processing technologies for health insurers in Singapore and the ASEAN region. And I know that she's got a long list of awards on her bio, including ARC fellowships, Monash University Vice Chancellor's Award for Excellence in Research, the Singapore Prestigious Engineering Award. She's also recognised as one of Singapore's inaugural 100 Women in Technology, and recognised as one of Asia's top 50 women technology leaders. So fantastic, fantastic set of experiences to help guide us. She also holds a graduate diploma in information technology and many other degrees, including a PhD, all from Monash University, where she's based now. So I'll turn over to you, Shonali, for the talk. Thank you very much.
Thank you so much, Janine, for that very kind introduction. It's really a pleasure, a privilege, and an honor to be here. Thank you so much, Jackie, for having me here and inviting me to speak. I thought I'll start with a very simple question. How many of you have engaged with some kind of AI, ChatGPT, Gemini, whatever, in the last 1 week, 1 month? Yeah, okay, that's the entire audience. Okay, that's great to see. Well, that's 90% of the audience. So, you know, when I think about where we live, when I think about information technology, and I am a computer scientist, I look back and I think that if you go back 30, 40 years, right, every 10, 15 years, we do face some kind of technological disruption that just changes the way 6 billion people live on this earth, okay? So I'm going to go back right to the 1980s when Sir Tim Berners-Lee proposed this idea that you can have some document information in HTML pages that can all be linked and delivered over this infrastructure called the internet. Well, and that sort of unleashed the information superhighway, right? So basically now information just became accessible to people at a scale that was unimaginable. It created all kinds of new enterprises, new ways of studying, new ways of working. Forward another 10, 15, 20 years, I think it was 1998 maybe. I was doing my master's by research at Monash, and I remember sitting in the tea room and everybody was talking about this thing where, gosh, it's so much better to search for information on the internet, right? There were a couple of kids from Stanford University and they had created something called Google, basically, yeah. So before Google came, we had search engines that would only look at the title of the document. And these two people sitting in a garage somewhere in the Silicon Valley came up with a method where you could search the whole text. And that just changed the way information search happened. I remember I was told, actually by the Vice Chancellor of Monash University, I don't even remember, that there was a time that you couldn't use Google in the Monash library. It was banned, okay? So can you imagine that was the state of play? And now Google is not a noun, it's a verb, okay? So I mean, sorry, it's a verb, we say Google it, yeah, that's right. So then you forward another 10 something years, okay? And there was a moment, I mean, I'm old enough, I remember traveling where you had like books, you had to go to a computer center to send emails to people back home to say that you're okay in some foreign country, right? But today, all of us, we cannot live without this thing, right? So there was a moment somewhere in 2007, I think, when Steve Jobs stood up and said, here is this thing called the iPhone. Now, think of it, this thing is as important as our liver and kidney. If you lose your phone, the kind of panic that you feel, right? And when these things came, there were people like, oh, you know what, I don't think I want this phone. Today, I don't know anyone who doesn't want this device anymore. I don't think we can live without it. So similarly, I think today we have reached another point of inflection. We have reached a point where this thing called AI is upon us. It is changing as we speak, the way we live, the way we study, the way we work. It is a disruption. It is definitely we're going to see huge changes. If I can stand here and I can predict all the things that are going to happen, I would be lying if I said so. I also cannot see exactly where this is going. But I think what I want to do is spend a couple of minutes on my own journey. Whatever we are seeing today, it's not like this suddenly appeared like 3 months ago or 12 months ago. It's a technology in the making for decades. The word artificial intelligence was coined, I think, in the 1950s. There was a group of computer scientists who met and said that can we have some really intelligent systems that can do that can basically do all our work for us, okay? I don't think they knew that this is going to happen now, but it has. So I just want to give you a little bit about my own journey, because today today I'm not going to present you something from a research paper. It's from my own experience of delivering an AI technology which works at scale today, but we had to do so in a very responsible way, navigating regulations, compliance frameworks, and so on, and making sure that the framework is very ethical and functions in a way that doesn't disadvantage people, right? So I've learned a lot from that. I'm going to talk from experience. So that framework that I'm presenting is what we used and what we were able to do. I must caveat that by saying that was machine learning in a traditional sense of the word. We've now moved into a space where we have generative AI and an emerging agentic AI world. And I will talk a little bit about what that means and what other people are doing in the space of ensuring that guardrails can be put into place. Okay, so I started off, just like everybody in this room, mostly, I suppose, as a researcher. I did my PhD at Monash University. I was a ARC fellow. I did all the things that researchers do: publish papers, supervise students, teach students, academic work. And then I left. I left in 2011. I went off to Singapore, and I've spent the last 15 years there. I was in an organization called the Agency for Science, Technology and Research. Now, the Singapore government, this is the Singapore government CSIRO equivalent, and I worked in the Data 61 equivalent. I was the head of data analytics there. I had a great team of about 75 data scientists, about 50 PhD scientists, and about 20-25 engineers. This was my pivot from research to innovation. So I'll tell you a couple of data stories just to keep this light and friendly before we get into the heavy, lifting of guardrails and ethics. So innovation to me is where you take your research and you see something happen in the real world. I think a lot of you do amazing work. I've been hearing about the kind of work that the two ARC centers of excellence do, and I think, that's real. You're really developing policies and making a difference in people's lives. Sometimes as computer scientists, we are very in the laboratory, we are developing algorithms, and we don't really see the impact in the real world. And for me, that pivot to A-Star was where I was told that we have to work with industry, we have to work with organizations. So today, whenever I go to Singapore, and I go often enough, and I take money from an ATM machine, it's the DBS Bank, the largest bank in Singapore. We had a joint lab with this bank. Whenever I take money from that ATM machine, I feel very happy because I see a little button on that machine, and that button is something that I helped to happen, okay? So I'll tell you what the story of that little innocuous button that nobody thinks about. So DBS has, like everybody in Singapore, it's like the national bank, so everybody has an account. As a result, the ATM queues tend to be longest at the DBS ATM. All the other ATM machines have shorter queues. So this is not a good look. So they came up with some process for fast cash. This is 2012, something like that, like long ago. The idea of fast cash is, if you're taking $100, $80, you don't have to press 6 buttons to say savings, blah, blah, blah. You just say fast cash, take your $100 and you go. We were looking at DBS data, and we found that 80-70% of people who could take a fast cash denomination were not taking that, right? So this is like strange. Why not? So we told that to the CTO. I remember this conversation very well. He said, it can't be. I said, that's what your data is saying, okay? And then he asked me, so why is that happening? He was a bit annoyed. So I told him, look, I don't know. I'm not a banker. You gave me your data. I looked at the data. My team has found this insight. So he said, okay, you know what? I don't think this is right, but I'm going to keep some people queue up at the customer agents, service agents, talk to the customers, hear the voice of the customer on the ground. And rightly, they found out that people were not using that fast cash option because in an attempt to over-optimize, they hadn't provided the print receipt option. So if you did 6 steps, you got a receipt, but if you pressed fast cash, you didn't get a receipt. So they added that. So this is like where you take innovation and you sort of research and it becomes something in the real world. That's innovation, right? But then I was very confident. I thought, we're doing all these amazing things. We're changing banks. We're changing so many things. We worked with all these, companies. I thought, what? Let's do a tech startup. Let's get together. A few of us from A-Star. We left A-Star. the well-funded world of, salaries and government bonuses, and went off to do this startup, bootstrap, okay? Oh, 3 years, we'll be done, we can change the world. That was the biggest mistake, okay? It was not 3 years, it was 7 years. It was the hardest thing that I ever did. But it was extremely rewarding. I was just telling Katie, I think that, in that journey you find yourself. It's the toughest thing to actually build something real that people will use. I think along the way, made many, many mistakes, but ended up developing this product called Smart Claims. That's my claim to fame. We basically landed on this problem with health insurers that they wanted to automate their claims, and they were wondering whether machine learning can help them with that. So we found by working with them that we could firstly automate claims, but we could also detect fraud, waste, and abuse. I want to tell you this, that health insurance is an interesting area. It's the only area that I can think of where the person who's selling and the person who's buying, everybody has the same objective. Everybody wants you to be very healthy, not go to hospital and live very long, because the minute you go to hospital, you make a claim, you cost the health insurer. You also want to remain healthy, you also don't want to go to the hospital, right? So anyway, it's an interesting area. The other thing I found in this journey, and I've looked at health insurance data from across the ASEAN region now, it's like, unlike auto insurance and so on, fraud doesn't come from the policy holders. Fraud, waste, and abuse in health insurance, in health, typically comes from providers and doctors, the hospitals and the doctors. In fact, there's only one fraud modality that comes from the policyholder, which is non-disclosure. So sometimes people don't disclose some kind of illness that they have. But other than that, everything comes from the hospitals and the doctors. Anyway, we built a technology which has transformed the way Singapore processes health claims today. These were some of the first AI systems that were onboarded in large insurers. This is a regulated environment. It's regulated by the Monetary Authority of Singapore. So we really had to navigate AI deployment at a time. So we did this around, by 2020, we were already doing this for many insurers. So we were really at the forefront of delivering AI and machine learning at scale very, very early in the piece. So there were no rule books, there was very little to guide us, so we had to learn as we did this, and that's the journey that I will share with you today. I won't go into all of that. Okay, sorry. So I want you to think about something here before I go into, what are the 4 or 5 things that you think about when you deliver AI and you put guardrails into place, right? The first thing is to understand that an AI system, a machine learning system, is different to a traditional IT system. Traditional IT systems are those that pay your salary, HR systems and so on, right? Those are completely deterministic. If you are a senior lecturer, you will get paid this much on this day. There is no doubt about that. AI systems tend to be probabilistic. All machine learning models and AI models will give you an answer with a probability score attached to it. It'll tell you that, yeah, it's highly likely that this person will leave this organization in about a year's time. We actually did that as well. We could predict in some cases who will leave the bank in about a year's time, right? So you can predict who's going to leave and you can do something about it. But it comes with a probability score. But when you think of that, so that is one big change. The other is that there are many cycles in AI. It's not like something you do once and you forget about it, because your data evolves. And so it's really important to keep training and retraining these AI systems, but in a very controlled manner. So once you have an AI model, it's not like that's the end of it. You have to decide that, okay, how frequently am I going to retrain this? That's a function of how often your data will change. If your data doesn't change that much, you could retrain it once a year. If it changes very frequently, maybe you need to change it once a month. It's very application specific. So you have to think about how do you want to keep retraining this. And every time you retrain it, you're basically creating a new brain. So now the question is, you have to validate this brain again. You can't just say retrain and deploy it and say make decisions. You need to check whether this thing is working, because maybe the new data was different. Maybe you lived at a time when COVID was happening, right? And so whatever was trained in that year, maybe you need to forget everything, because the next year is not like that. You come back to the normal way of living. So you have to think a lot about how your data is evolving when you use machine learning and when you want to use machine learning at scale, right? So that's one of the things to think about. When we use these kind of systems, often people only think of the model, right? So I've trained the model, now I can ask the model a question and I'll get an answer. That's actually not true. You have to think of something beyond the model. So think of the model as a little circle, but you want this to be in a bounded box. What is the bounded box? This is where you put guardrails in place, okay? So I'll give you an example. Now, when we were using it in the context of health insurance claims, if a claim comes in and you say that you want to automate using AI, so you want to trust the AI to make the right decision and you want to automate it, right? So you can say something like, okay, if the claim comes in and the machine learning model says approve, and the machine learning model has very high confidence, so the probability that this is right is very high, it says 95%, excellent. But you still want another level of guardrails to say, look, what if it makes one mistake, and that mistake was for a claim which was $200,000? Can we take that risk? No. So you want to bound it further and say, okay, I trust it, but up to $10,000. So if it makes a mistake, then there is that sort of bounding that you do. Now there could be another case, right? Let's say a claim comes in, and the machine learning model says, sorry, Shonali, your claim is rejected. So what do? What if you automate that and it makes a mistake, right? So now the mistake is really, let's say that I'm actually eligible for a claim, right? That's why it's a mistake. So it should not have declined my claim. So what can we do now? What do you think we should do? There's no, I'm happy to take any answer. No? Absolutely, spot on. That's exactly what you have to do. So that's putting it into that bounding box to say, this is a risk which we can't take. We cannot deny someone who is eligible for a claim at any cost. It doesn't matter. So we will not automate that decision at all. That decision will always go for a human assessment, for a review. So this is how you have to think about doing AI. When you want to make and trust AI, you have to think of all the scenarios where what is the implication of the decision that it's going to make. I was looking at this and I was talking to Janine. My brain, when I looked at that, I was thinking, oh, if you have all this data, can we predict the trajectory of, let's say, a particular individual? Are they going to go through that path, or are they going to go back into that cycle? You have enough data. Is it possible to predict? I don't know. I mean, this is research, obviously. But the question is, then the two questions to ask is, what if it predicts that this person will go on the forward path, and what if it makes a mistake? And what if it predicts that the person will go on the decline path, and what if it makes a mistake? Right? So you really have to weigh these things up. I can't answer the question today. I mean, that's a bigger discussion to be had. But I'm just trying to tell you that once you start doing AI systems and using AI, you have to think like that. Because you can't just trust everything that's going to come out. That's why I said it's a probabilistic technology. There's a probability. 99% of the time it may be correct, but 1% of the time it may be wrong. You need to cope with that, and you need to go into the minutiae. You have to look at what if it says yes, and what if it says no, and what if it gets it wrong when it says yes, and what if it gets it wrong when it says no. Once you start thinking like that, you then have the guardrails, you design guardrails, and you put them into place. So that's really the most important part of thinking about AI systems. That's the one thing that I learned. The way I learned this, though, was because as an academic, I was used to writing papers where I could write a paper and said, oh, my machine learning model is 98.4% accurate. Everybody else who used this data was getting 97.6, so we are the best in the world. So I went and told this to all these health insurers and banks, and they all looked at me and said, so you're wrong like 1% of the time? Gosh, that could cost us like $1 million. That could get a lawsuit on our doors, If you deny somebody a claim, and that person, comes and, it's reputational damage, the risk is huge. So you have to bound the risk. So my whole point is, it's not about not using AI. It's not about being scared of this technology. It's about understanding how it can be used, harnessing its power, but really thinking through how you put efficient, enough, safe guardrails in place so that this works for you. And actually we did that, right? So today, 75% of Singapore's health insurance claims go through our engines. It is transformational. Before our technology was deployed, it would take somebody about 7 to 10 days to get their check back in the mail when they filed a claim. After we deployed this, for many of our insurance clients, about 50 to 70% of the customers, and I'll explain why 50 to 70 to 70% of customers would get notification within a few minutes and payment within the day, right? That's a huge change. When we look at other areas where they couldn't even do it, fraud, waste, and abuse, impossible to kind of actually detect fraud, waste, and abuse in real time because a claims assessor is given 30 minutes to process a claim. They can't remember all the kinds of things that you have to look for. But we found that we could actually detect a lot of fraud, waste, and abuse and save a lot of money. Now, you might think that is actually a bad thing because you're detecting things, but it's not. Fraud, waste, and abuse means that the cost of healthcare keeps going up. As the cost of healthcare keeps going up, who's paying for that? All of us, our premiums go up, right? So it's really very important to identify those people who are abusing the system and try to address that. So I'm going to talk a little bit about the fraud waste since I came to that part. Don't ignore all of this. Okay, so here's an example of, Here's an example of, actually this is a true case. So here the claim came from some ENT center, and the disease was something called rhinitis. If you know anything about it, something to do with the nose. I'm not a doctor, right? But this doctor had ordered an endoscopy and a gastroscopy for the patient. That has nothing to do with the nose, right? So this is the kind of thing that if you're just trying to see the cost and you think, oh, it's $1,000, $3,000, okay, I'll just let it go through. But this is where the AI engine will immediately flag these things, okay? So it's a powerful technology if you leverage it well, but you have to put the guardrails in place. That's my whole point. Without the guardrails, this could never have gone in, right? So I'm going to talk about a few things that we all need to think about beyond the guardrails, okay? There are 3 things. I'm okay for time? Yeah. Okay. There are 3 key things that we have to think about. And within managing AI risk, there are about 4 different things. So there are about 4 or 5 things. So yeah, 5, maybe 6, sorry, Janine, but yeah. The first is that when we use this kind of technology, we need to be able to explain the decision. Why did the AI say what it's saying? Why does it say, yeah, let's give this person something, let's not do this, this is going to happen. You need to be able to explain it. Now what happens is that people start thinking about how does a neural network work? What is the mathematics of the algorithm? Actually, that's not the key point. I'm going to ask you this question. If you went to a bank and you applied for a credit card and you got rejected or you got the credit card, the person who was assessing your credit card application or mortgage will only be asked why they rejected or why they didn't reject. Is somebody going to ask them which neuron in your brain fired? No one is asking that question. So we should also subject AI to the same standards that we subject human beings who are doing that sort of work, right? So that's a key question. You need to understand why a decision was made and not how. In terms of understanding why a decision was made, there are many ways of doing it, but I'll try to keep this non-technical. The way that I found most useful was to understand how the human beings in that domain worked, because they are looking for some answers, right? So if you are looking at this application here and you want to predict the trajectory of someone and you're working in this ARC center, it's really important for the AI scientists to work with the people who understand this domain, understand what you're looking for. When you look at this and you want to recommend certain policies, how do you do it? Once you understand that, then you bring that into the AI system, then the AI system starts behaving the way you expect it to behave as a researcher working in the Life Course Center, okay? So that's really the critical part of this. You need to have domain expertise working with the people who know data and AI. When that happens, magic happens. I'm not it's not like I was born into the world of health insurance. I learned it by working with health insurers. But I'm a data scientist. I'm a machine learning scientist. When I understood what the health insurers look for, I was able to design an AI system that helps to answer the questions that they need answering, right? So if you just randomly take your data and give it to somebody and say, build me a model, you will not get that layer of explainability which you need to build, probably not automatically as part of the AI or machine learning model, maybe even as a separate part of interrogating the machine learning model, right? So this is something that you also need to think about. Explaining the decisions, very critical. That usually happens if you get your machine learning scientists to work with the domain experts, and together you decide how you're going to explain this. How are you going to explain each decision? When you say that there is fraud or something, you have to say, oh, I'm saying there's potential fraud here because rhinitis is not linked to, gastroscopy, right? That's basically the kind of detail you need, okay? So explaining decisions, very important. Focus on why, not how, and I've kind of, explained that. But sorry. Yeah, we've done a lot of research, so I won't go into all of that because okay, so this is another very simple example, right? So here, the AI is able to look at the cost of this particular, some kind of cataract, some lens to do with the eye, and is able to immediately tell the assessor that this lens was a lot more expensive than typically lenses that are, or implants that are, put into someone's eye in these kind of hospitals, right? So this is the kind of thing, again, it's able to learn. It can process data the way a human being cannot process data, right? So this is, but if we don't give that level of detail to the person who's reviewing this, they can't do anything. If you just say, oh, there's fraud, waste, and abuse, this is an outlier, what will they do with it? They can't do anything with it. So this is why explainability is really, really critical. Okay, now I'm going to another part. So explainability, absolutely important. The first point was that you really must think about the kind of risk. I'll talk more about it when we go to managing risk. But AI testing. So I have a 5-step process for AI testing. Most people do 4, but we do 5. I recommend 5. I'm going to talk about that because I had a colleague of mine who was doing a PhD at Singapore Management University who basically interviewed a lot of companies that were deploying AI and machine learning in the real world. And he came and said that not a lot of people do the last thing that you do, right? So the last thing is really, really important. So I'm going to talk about all 5. So when you build an AI model, the first thing that you do is back testing. Okay, so back testing is a very simple idea. When you have, let's say, data, let's say you have 100 records, you take 80% of your records and you train your model. Then you test that model on 20% of data that was not used to train the model. You get a sense of how good your AI model is. Okay, is it getting 90% correct? Is it getting 95% correct? What is it getting? Now, if it's not good enough, you can go back. You can tune your model, you can do whatever you want, retrain it and retest it. Okay, till you get to a point where you know that this brain is learning things the way it has to learn. Think of AI as a brain. You're giving it a lot of input, it's going to learn something, okay? So once you do that, the next thing that you should do is what we call forward testing. This is out of sample, out of time. So basically forget about this 100 records, get another 50 records that was not used for training, testing, run it through this. And in that case, actually, if you're doing it in the real world, what your clients or your collaborators should do is not give you the answer. This is like the actual exam for the student. So for instance, when we worked with these insurers, they would hold about 6 months of data and give us the claim without the decision and say, run it through your AI and tell us the decision and we'll compare it. So it's really like a test, it's an exam. Okay, so you do that because that will give you another level of validation. required to show that you've trained this thing correctly. Okay? Then, before you actually deploy this model into production, where you really want it to make decisions every day, new data comes in and it's going to make decisions for you operationally, you go through a whole process of IT testing. This is standard, information technology systems testing, and user acceptance testing. So here you get a chance to stress test your AI. So let's say there are these outlier cases which don't happen often in the historical data, right? Maybe if we were doing a model like that, maybe there are people who live in certain communities which are underrepresented in the training data. You sort of simulate those cases and you sort of stress test your model. That's the third level of testing, okay? The fourth and the fifth are really, really important. The fourth is once you put it in place in production, you don't trust the AI. You don't let it make any decision. You have a 1 month, 2 months, maybe 3-month period where every decision that the AI makes should be reviewed by a human being. Then you look at the discrepancies. When AI said this and human being says no. And you try to understand, where is the AI making a mistake? Sometimes the human beings also make mistakes, okay? That's what we found, okay? So you need to basically do that evaluation, what we call hypercare or parallel testing. The last is, now you're confident, you put this in place, this thing is working for you. It's making decisions at scale. So what do you do next? The last step is, you basically you have to do like a quality audit. Every month, you go back and take 100 decisions which the AI made and manually review it with an expert to see that it's still performing the way it was intended to perform. Is there a degradation? Is it making some kinds of new errors that you did not see, right? So you have to put this really strong testing framework in place to have confidence that this thing is working. Okay? So now that is traditional machine learning. When we go to generative AI, we are now heading into some other uncharted territory, right? Okay, so if I were to ask you, what's the difference between, say, generative models and machine learning as we knew it? The simplest answer is that, think of it like this. The traditional machine learning models are trained on very specific data, typically structured data. So machine learning algorithms, traditional algorithms, work on data which exists in databases. The generative large language models were trained like this. ChatGPT is OpenAI, ChatGPT, Gemini. The way they train it is basically, they take the entire internet of all the documents there is, all the information there is. This is why it costs billions of dollars, right? And you're training this very, very large neural network. And this now, because it's seeing so much of documents, is actually able to understand language. That's why it's called a large language model. So what it does is, it takes every word, and it looks at all the documents where this word appears, and it learns the context for that. And it starts building connections. Now that it has learned language, it can generate language for you. So you can go and say, hey, I need an email. I need to send this email to my boss. Can you do me this, this, this? So now it has got the power of language, so it's able to generate. It's not intelligence at the level of human intelligence as we think of it, okay? It's really just a very, very large neural network that has been trained. And similarly with images, if you feed it like 1 billion images of all kinds of artworks, then you can say, okay, you've seen all this art now, give me an image of something, and it's able to generate it. So hence the word generative. So it's actually generating, not just recommending things, okay? So this is how large language models have been trained. Now, when you go and use this kind of technology, firstly, you must understand what it is good for. If you can do something, if your data is completely like a structured database and you want to do a prediction of someone is, able to, do you want to give someone a loan or something like that, don't use a generative model. Actually, these are very expensive. You don't have to use it. You can just use traditional machine learning models if your data is already neatly packaged in a database. The time to use generative AI is if you have a lot of unstructured document information. Now, I think in centers like the two centers here, you probably have a lot of document information, and so generative AI is powerful. For what purpose? you use generative AI to extract structured information from it, because you can query these documents. You can say, okay, I'm giving you a document. So I'm doing this work with a medical researcher, right? And she has a lot of clinical notes, and this is in the space of aged care. And we're trying to predict falls. So there's sometimes nobody says that someone fell, but it would be something like, oh, they had a fracture, they were taken to the hospital, but nobody has recorded the word fall there. So generative AI is very good at in that sort of analysis, because you can look at these documents and say the likelihood of a fall occurring was very high. So you can now get information which is sort of clothed in language, in layers of language, and you can extract insight from it. This is the best use of generative AI, in my opinion, where you have large document corpuses and you can analyze things and you can extract information, put it into this nice, neat packaged box, and then you can use traditional machine learning to predict what you want to predict. Would I use generative models for prediction? No. The other thing that generative models are very good for is generating synthetic data. That's another application I found that it works very well for. So let's say in maybe when you study life course, you have, I don't know, 10,000 people that you studied over a period of time. But for machine learning models to predict, you need maybe 100,000. Right? So this thing can generate similar data points, but synthetic data that helps to train a model. So you can think of it like that as well. These are the places. So again, this is why it's very important to work with people who know these kind of things, because when you work with them, you get this nuanced view of AI, which is I think very powerful. When domain experts come together with AI scientists, that's the magic that happens. I say this again and again. I will share this with you. I have given you the slides. Please look at this particular one. I don't know if I can click anything. I can't, right? No, okay. So I won't, but this case study, this was a study that was done by an organization last year called AI Verify. AI Verify is a government sort of initiative in Singapore. And in my view, this was the first formal and serious study of testing generative AI applications, right? So if you go into that case study link, which we will give you, you will find about 15, 18 different case studies, some in health, some in finance, some in social sciences. You'll find something which is interesting. When you look at that, what they did was they had companies or organizations, even hospitals, which were building models. They married them with organizations that were testing models. So this is like red teaming, right? The people who build the models are not the people who are testing the models. You put this together and you say, come up with a framework for testing these large applications that are built using large language models. So there are many insights that come through. One is that you really must test that the scope of the application, like, because with large language models you ask prompts, right? You say things like, hey, you know what, I want to commit suicide, can I do that? You don't want this question to be answered, right? You want to say, please go talk to a psychologist, talk to a doctor. So you need to make sure. So how can you make sure that you put guardrails for the specific application that you are building? A very simple guardrail is to say anything outside of that domain, don't answer. Right? If you just use the other approach of not trying to figure out all the things that can be answered, just say that anything outside of the domain of life course or violence against women, that's all you want. Anything else you're not going to answer, right? So you can put those kind of guardrails. You need to do that. So when you think of testing, my point is it's still very, very important to do it, but the way you test generative AI applications slightly different to the way you would test traditional machine learning applications. And making sure that it doesn't respond to prompts that you don't want it to respond to is a very, very critical part of putting into place, right? Okay, now we've now sort of emerging into this world of so-called agentic AI. Everybody thinks agents are very new. Actually, agents are not very new. About 20-something years ago, I think, the first software agents course that the faculty of IT taught at Monash, I actually taught that long, long ago. So what's a software agent? A software agent is like a software robot, okay? So the idea of an agent is slightly different to a machine learning model. It's a little bit more than something that gives you a response or a recommendation. Machine learning models tell you, okay, it is likely to rain, 80% chance that it will rain, right? It's just telling you something. It's not doing anything, okay? Likewise, even a generative AI is like you can ask it more natural language style prompt questions. It's telling you something, right? But with an agent, you have autonomous execution. So this thing is not just recommending something to you. It's an agent because you're giving it the authority to act on your behalf. Okay, so that makes an agent a lot more, how shall I say, what if it does the wrong thing because you've now given it the power to act, right? So as you move into this space, testing and thinking about putting guardrails in place becomes even more critical, right? Because this thing can actually do something. And if it does the wrong thing or does something harmful, then that's where you need to put a lot more into place, right? So these are just some recommendations. It's not like everyone is doing this. I mean, people are still just, it's very early days. People are just navigating this world of agentic AI. But the whole point is that you want to make sure that you limit the scope of what it's supposed to do. If this AI is supposed to book travel for you, then make sure that's all it's allowed to do. And make sure that before it actually passes your credit card to someone, it comes and asks you, right? Put a cap on how much the AI can spend, just like the smart claim assessment tool could spend, right? So you have to really think about what is the AI agent supposed to do, and make sure that you sort of make it behave within the bounds of what it's supposed to do. Make sure that it comes back to the human who authorizes this agent. Make sure you have enough audits and logs of all the actions that the AI agent took. So again, I will link it to my last step here, post go live quality checks. We did that with claims, but you can do that with agents. So every month, look at the audit logs of all the actions that your agent took. Maybe not every month, maybe every week, who knows? Depends on what this agent is doing. Okay, so you limit the scope, make sure you get feedback from the user before it actually makes some real decision in the real world. You make sure that, user input before any critical action. Role-based access, so make sure that the only person who can instruct the agent are authorized people. Like you should have some kind of password to be able to instruct the agent to do something, right? You cannot have everybody accessing this computational tool and saying, oh let's just book a cruise for like $200,000 for Shonali and she'll be bankrupt, right? So you don't want that sort of thing happening. And keep looking at the decisions and detecting anomalies and fixing things. So again, my message is never to say that technology cannot be used. It's just a tool. If we use it intelligently, if we put enough constraints and think about how it's used, then we will be able to make sure that we get the benefits of this technology, but manage the risk. That's really the core message. Okay, I'm going to talk about managing risk. Okay, there's a few things that I think everybody must do. There are 4 things in addition to the testing and the explanations. The first thing is, whenever you do an AI project, you want a project level governance committee, okay? And this governance committee, do I have time? Okay. This governance committee must include people who are basically all the key decision makers. You want the business, when I say business, I probably should have edited the slide, the people who know the domain, right, the experts, okay? You want those people in there, you want your technology folks in there, you want your data and AI people there, and you want whoever manages risk there. So you basically want to sit there and say, we want this AI, what do we want this AI to do, okay? And then you want to basically identify what are the key metrics. We want this AI to improve efficiency, automate decisions. We want it to help us predict who are the at-risk students who are likely to fail. That's something that we're doing at Monash University right now. So can we do early intervention? If we predict that a student is likely to not do well, if we can identify that early in their course, then can we actually put some interventions in place? So then the question is, what if the thing gets it wrong and says that Shonali is at risk when she's not at risk? What would we lose? Yeah, it would cost us something because we would have, put some support for Shonali which she doesn't need. But that's okay, maybe we can bear the cost. But what if it fails to predict someone who is going to fail? What's the risk of that? At this point, we have no idea who's going to fail. So you know what? Anything that improves it is probably, we will have to understand that it will not catch all the students who are at risk. But if it gets us 4 out of 10, that's 4 students who have been prevented or given some support. And maybe of the 4, 1 would not have failed, but so be it. You really have to sit there and look at the metrics of what you want to achieve and what is the risk. This is what I mean by a project governance committee. Every AI project should have this. The second thing is, I already spoke about this. For that application, the context-specific risk. I just mentioned the student case. You have to look at the context of that application, be it claims, be it students, be it people who are, going through this trajectory, of life course, whatever it is. You need to understand the specific risks of the AI making the right decision and the wrong decision for different kinds of people, right? Because there are those 4 decisions. For a particular individual, it might say yes when the answer is no. For another individual, it might say no when the answer is yes. You have to basically weigh these risks and come up with mitigation strategies and tolerance thresholds. What can you tolerate? What can you not tolerate? Those that cannot be tolerated, as we discussed, have to go for human oversight. You also cannot have human oversight for everything, then you might as well not have the AI, you can have the human being sitting there. So you have to find that happy sweet spot of what you can accept and what you want complete oversight. You cannot take any risks, okay? So this is something that you need to put into place. All this needs to be documented, okay? I won't go into that. I spoke about this a little bit, but here is a formal framework because AI models are not fixed in time. I said that as data evolves, we have to keep training the AI model, so retraining it. So again, this is a decision that has to be taken by the project governance committee to say, how often are we retraining this model? What kind of data will be used to retrain? Because you cannot keep on retraining forever, right? If you say you're using 5 years of data to train a model, after a year, you have to use the most recent 5 years because otherwise it's going to remember things which might not be relevant. So you need to decide what is the frequency, the schedule, and when you retrain, as I said, sometimes there could be problems in the data. I'll tell you once, this is a very, very simple error, and maybe today's AI may not make that mistake, but going back 7, 8 years, we got a call, and that's the problem. When you do a startup, it's not like you're an academic. You can't say after 5 o'clock, I won't check my email. If a client calls anytime, I'm like, yes, I'm there, okay. So the question was, suddenly your AI is not giving us the business lift, automation levels, it's not working. So we had to go and look at this. So what had happened was that they had given us data, initially the data from the databases, when the field was empty, it was null, null, okay? Somewhere somebody changed this and it became an empty string. So the null became blank. So the machine learning model got confused and it didn't behave the way it was supposed to behave. So you see, data can change, data can drift. You need to look at that drift as well. So there are ways in which data scientists do this. But my point is all this needs to be thought of, okay? The retraining data set, the period. Finally, the approval process. When there's a new model, who is going to press the button to say we've looked at all this and now this model can make decisions for us? Okay, so that approval matrix has to also be determined. Finally, the acceptance criteria. You have to make sure that you tested this new model and it's doing exactly what you expected it to do. In that case, it wasn't. The new model was failing. That's why they called us. Right? So you need to put all these things into place. This is what I mean by putting the responsible guardrails into place. Finally, there's something called compliance frameworks, depending on which industry you work in. If you work in health in Australia, it will be the TGA. If you work in health in the US, it could be the Federal Drug, whatever agency. I worked in financial services in Singapore, so it was the Monetary Authority of Singapore. So whatever AI regulations they have, sometimes organizations will have AI governance processes. So you have to fill out documentation to say this is our project, this is the AI, this is the data it's trained on, this is the decision it's going to make, this is how we'll deal with all these decisions, etc., etc. So this basically, sometimes organizations will have governance frameworks that you have to fit into. So you must make sure that you do all the compliance that you have to do. Most of the compliance that you do will focus on these 4 things in some manner, okay? Some may have 3, some may have 4. But you have to look at all of these things and you have to document. You have to make sure that your AI is doing all of this. So how will you do this? Fairness. Okay, I'll give you an example of a case where we found out that the AI was doing weird things. So somebody, and this was long before generative AI, okay? So there was a HR, screening of CVs. And there was like this process of selecting people for CXO level positions. And all the CVs were fed into this AI engine. And the AI engine never selected any woman for an interview because it saw that it learned, looking at the data, that almost 9 times out of 10, it was men who became CXOs. So this AI decided that if you are a man, you can be a CEO, CTO, because it never saw enough women. It's a very simple fix, right? You don't feed gender. You don't feed information that will make this, not be unfair to certain demographics. But in some cases, it's not as simple as saying, I'm going to leave all demographic information out. So in the health insurance space, we could leave out race, but we could not leave out gender and age because certain diseases are specific to women and certain diseases are specific to men, and age, some diseases are age related. So you have to bring those variables in, but then you must show that it's not discriminating against any gender or any particular segment of the data, of the demographic. The other thing is ethics, making sure that the system do the right things. So in this case, in the case of smart claims, I was told very clearly by all the insurance customers that, we cannot tolerate even a single error if there is a rejection. So fine, the ethics around this is that it has to go and get reviewed by a human being. So the AI is not making the final decision. Right? So it's not going to cause harm to anyone by declining someone who is eligible for a claim. Again, in each case, we have to think about what is the harm that will be caused and how do we mitigate it. Accountability, clear ownership of these decisions. So when you go through that governance process and you put into place this idea that, okay, if the AI model is retrained, who's going to approve the new model? Who's going to make sure that it's behaving the way it's behaving? And for every decision that it's made, you say that, okay, within this boundary condition, the AI is allowed to make the final decision. Anything outside of that, a human being reviews it, right? So this is accountability. You have that very clearly modeled there. Transparency, I said this before, explainability and transparency are very related. You really need to understand how it's making the decision and why it's sort of giving you the decision, but also how, in the sense, what kind of data are we feeding it? Are we making sure that the data is correct and valid, and so on and so forth. So these are some of the things that we have to put into place, and often this has to be documented. So if you do all of these things, yes, you may still have an AI which will sometimes go wrong and make an incorrect decisions, but you have done whatever you can to put enough of guardrails to make sure that you've been responsible, ethical, you've thought of the consequences of the errors that this AI engine can make, and you're working with that framework. So this is something that we developed along the way. Hopefully you find there's some learning in all of this for you. I won't go into that, and really I was told there's only 5 minutes, so thank you very much. I hope you found that useful. Thank you.